Hi, welcome to today's chemistry tutorial. If you have not subscribed before, just click on the subscribe button below, leave your comment and click the bell for more notification. You can equally send your questions via my email address, which is written below. Today we are going to discuss about the Boyle's law. So here we have Boyle's law. This law was one of the laws propounded by Robert Boyle in 1662. What is the Boyle's law trying to tell us? The Boyle's law shows the relationship that exists between the three parameters of gases, that is, the volume, the pressure, and the temperature. What does the law say? The law states that the volume of a given mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. Or the pressure of a given mass of a gas is inversely proportional to its volume, provided the temperature remains constant. So one of the constants here is that of the temperature. Once the temperature is constant in any of the questions, that means the formula to be applied is the Boyle's law. Now mathematically, the law can be represented as the volume of a given mass of a gas inversely proportional to the pressure. Here we have V equal to, once the sign of proportionality sign changes to equality, you apply your constant all over P. So make care the subject. We have constant equal to Vp, that is V times P, which is Vp. So because the gas constant is Vp, so here we have it as V1 P1 equal to V2 P2. The V1 serves as the initial volume, the P1 serves as the initial pressure, the V2 serves as the final volume, and the P2 serves as the final pressure. Now let's take down example with this. This particular law, what is it trying to say? From here we have one particular question which says calculate the pressure at which the volume of gas becomes tripled if its initial volume at 3.00 atm is 75 cm3, temperature being constant. So how do we get this particular question? Let's just take down the question bit by bit. Calculate the pressure at which the volume of gas becomes tripled if its initial volume at 3.00 atm is 75 cm3, temperature being constant. Under solution, the question have already told us the one of the parameters is constant, and that parameter is what? The temperature. So definitely you apply the formula. Your V1 P1 equal to V2 P2. So what are we looking for from this particular question? Calculate the pressure at which the volume of the gas becomes tripled. That means you are looking for the final pressure, which is the P2, and making P2 the subject. Here you divide both sides by V2 to give you V1 P1 all over your V2. Therefore, we have our P2 equal to, what is our V1 from the question? The first initial volume, which is 75 cm3, times the pressure is P1, which is 3.00 all over. Our V2 is what? Calculate the pressure at which the volume of the gas becomes tripled. That is 3 times the initial volume of the gas, and that is 3 times our V1. So P2 is equal to 75 times 3.00 all over 3 times, why the initial volume is what? The initial volume of the gas gave us 75 cm3. So the final volume is 70. Here should be 3 times 75 as the final volume. So P2 here will be equal to 75 cancel 75 is 1. 3 cancel 3 is 1. So 1 times 1 is 1 all over 1 times 1 is 1. And 1 divided by 1 will give us 1 atm. So this serves as the final pressure of the gas that was tripled, whose volume was what? Was tripled. Therefore, let's go down to example 2. What if a question like this is given to you? How do you apply the same formula? Here says a certain mass of gas occupies 150 cm3 at atm pressure, atmospheric pressure of 10 raised to power 5 Newton per meter square. The question says, what will be its new pressure? What will be its new pressure if the volume is reduced to 100 cm3, assuming assuming there is no change, no change in temperature. Now let's go down to solution of this particular question. A certain mass of gas occupies 150 cm cube at atm. So here we give us, remember the formula, your V1 P1 equal to V2 P2. Just applying that formula, you get your result. Therefore, under solution we have V1 P1 equal to V2 P2. So what are we trying to make the subject? Let's read the question and then understand the particular parameter that we want to make the subject of the formula. A certain mass of gas occupies 150 cm cube, which is the V1, at atm, atmospheric pressure of 10 raised to the power 5 Newton per meter square. What will be its new pressure? That means we are looking for P2. So P2 is equal to V1 P1 all over V2, which is equal to, our V1 here gave us 150 times, our P1 is 10 raised to the power 5, divided by our V2 is what? 100 cm cube. So we have it as 100. P2 here will be equal to 150 times 10 raised to the power 5 all over. Change the 100 to standard form to give you 10 raised to the power what? 2. So P2 is equal to 150 times, according to the laws of indices, the bases are equal, therefore the power should be what? Should be subtracted. We have 10 raised to the power 5 minus 2, which is P2 is equal to 150 times 10 raised to the power 5 minus 2 here will give us what? Will give us 3. So definitely here, you change 150 to standard form. P2 is equal to 1.50 times 10 raised to the power 2, then times 10 raised to the power what? This particular one. So P2 here will be equal to 1.50 times 10 raised to the power, because the bases are equal and they are multiplied, their powers should be what? Added together. So we have it as 2 plus 3. P2 is equal to 1.50 times 10 raised to the power what? 5. Then the pressure given to us, what is the unit? The pressure given to us was found in atm, which is the Newton per meter seconds. That is Newton per meter square. Then the final pressure of the question is 1.50 times 10 raised to the power 5 Newton per meter square. These questions were sent to me via my email address as usual. Then we're going to stop here for now. For more of the video, just click on the subscribe button. Subscribe, you get more of my videos every week. Then click on the bell for more notification. Thank you. Remember that what the Boyle's law is trying to pinpoint here is, as the volume increases, the pressure decreases. And as the pressure increases, the volume decreases. See you by this time next week. Thank you and God bless you.